Okay. Good morning, everybody. I'll try to make it short. Simon talked me into making a presentation, so I'll go for it. All right. Please come in.
Are we just starting? So perfect timing, please. Nice.
Okay. I'll talk about me for a bit. I'm a consultant at Thales. I've been building tools for making and breaking products for 2 decades, and the mission of mine was to enable you smart people to work efficiently. That was one side of the tools. The other side of the tools is the process part, which is to force you to do things the right way. And we try to have a fun while doing that. So that's all what I want to say about me. Okay, let's go to the next one. Oh. Oops. Okay, so I was hoping you'll. Okay, so this is a story. There's going to be very little code, even though this is a code meetup. There's going to be just very little code. This is more of a story about what we built. So once upon a time, we needed a build system that was reliable because our requirements were that for 30 years we need to be able to rebuild. And it's not that easy. If you ever if your manager ever asked you, there is the code 10 years old, can you build it? You know what you're against. So that was the motivation behind what I'm talking about. And we also went through a number of iterations of our tool chain. And there were always developers saying, oh, on my machine there is this version, on my machine there is this version. I'm working on the new of the tool chain. I'm working on the new release. Oh yeah, you need to go here, take this build server. None of that we wanted. So all the developers lamented like in a good story, and yeah, we have these DevOps guys coming on a big horse and try to save the day. And this is why what was the challenging? Why is it so difficult to keep the build environment fresh? Languages evolve. We all know that. We have a bunch of standards that 10 years ago were modern, and 20 years from now will be in the analysis history. Libraries evolve, so whatever worked with your library last week might not work in a few years. We have new version of toolchain. So even if your code language specification doesn't change, you still face the same problem that the code might not be compatible, the hardware might not be compatible because our toolchain happens to be custom made for our hardware, and the results might not be bit exact. It could be for many reasons. Optimizers are run differently on your version, or the packaging is different. Linker links it in different order. Packaging manager, whatever it is, packages in different order. Same with symbol extraction. So sometimes after the build is run, we post-process it and need to extract some symbols. None of that might be compatible from year to year. So this is what we try to solve. We set some requirements for us. We wanted the version of the build tool to be somehow tied to the source code version that we are running. If I come next year and I check out a specific version of the code, I want the build system to know what tool chain to use to be able to somehow download it or somehow prepare it, run the code on it, and be happy. We want the same thing to work on the developers' workstations and on the build servers. There is nothing worse than people going and scrambling which workstation to use, which build server to use. That needs to be avoided. We want, if there is a need to rebuild the build environment, reinstall the build environment, it needs to be automated. We don't want too much manual intervention because we are lazy. We DevOps are lazy, so we don't want to do the job. We want you developers to do your thing, right? And we want it ready for long-term use. Few other considerations. We assume our users don't know much. That's a very safe assumption usually. We didn't want to modify the build procedures as they were. So basically the tool chain needs to run as it was week before. It needs to run again. And as much as possible transparent to users. I know that our colleagues will disagree that we made it transparent, but we made it as transparent as possible, as we could. Okay, so what we did, we wanted to put the build environment inside of Docker, nothing new there. We wanted to, we decided that the Docker build directory, which is the directory for those who are not familiar with Docker. Sorry if I go too basic. So the directory that contains Docker file needs to be part of our source tree. And the reason is that I have one repository, and from that I can see exactly what my toolchain was at the time that I check out my commit. I check out my commit, I can look right into that Docker build directory, and I have my Docker file and all the external files that we are copying in. And we also have hashes of the remote files. I'm gonna talk about it a little bit. Why is it important? We do need to rely on things that we are downloading from servers. We are not downloading from internet. We are in insulated network, but we are downloading some stuff from an archive. Just because the file that I'm downloading has the same URL and same name, it's not the same file. We don't trust it. That's why the hashes need to be stored in the Docker build directory. And we download the file and verify it's the same file as it was when we placed it into the archive. If it's not, something else needs to happen. These things together, these three things together, give us absolutely good idea, or very good idea, of what is it that we are building. So from Docker file, all the external files, and validating the remote files, we can ensure that when I generate my build environment today, and when I generate it later, I'm going to end up with a compatible environment. Then we have a little run/build script, which is what users actually interface with. So users have to somehow start the Docker container. We are trying to hide it as much as possible. And that lives just inside of the product tree. And now how do we solve the issue of versioning? And this is exactly what I'm finally getting to what I'm talking about. We take 3 hashes of the Git and we take the images. So the build tree content, this content, corresponds to our tag. and network-based installs require some attention, which is these hashes. I don't know, I'm gonna just go quickly because I don't know if everybody knows what Git, what are actually tree hashes. So if it's too simple, I apologize. As you all know, probably, Git has objects in it, and every Git object has a hash. In fact, Git is nothing more than a file system full of hashes. And I'm not talking about the tree that you are seeing. I'm talking about the objects directory inside of your .git file, right? That's that file system. Most developers are familiar that you do your commit and you get a hash, and many people don't even know where the hash came from. It doesn't matter. It's opaque, but for this purpose, we'll explain it. Okay. We'll talk about two different objects. Forget commits right now. We are talking about trees. Before we talk about trees, we need to talk about blobs. Blob is just a bunch of bytes, and it's completely amorphous. A tree is a unit of organizing blobs and other trees. Again, this is very basic. I apologize if it's boring. This is just a quick drawing of how hashes are calculated. Every object has a header, content. It's run through SHA-1, and you get your hash. So, for example, I have my file here that contains hello world, new line, actually hello world new line, as you can see, and it's a blob of 13 octets. And this is the content. If I take this, I run SHA-1. I know my Git object is 980 and so on. That's my Git object. Every file containing hello world new line will have, in every Git, anywhere in any repo will have this hash. On the others, so those are blobs. You create your files, you get your hashes. Trees, on the other side, contains either references to blobs or references to other trees, which would be subdirectories, if you will. Tree organized exactly the same way. It has a header containing the word tree, followed by a space, size, followed by null, attributes, name, and hash, attribute names and hash. So, for example, in here, I have very complicated directory. I have one file in it. It's this file. And it has a tree right here, followed by 37, which is the length of the content. It has some attributes, 100644, which means it's 644 permissions, 100, it's a tree. It's a file, pardon me, it's a blob. The name of the file is hello.txt, and the hash is this string here, as you can see, 9880 0D5F and so on, right? That's my tree. I take this whole thing, run it through SHA-1, and I get my beautiful tree hash. This tree hash is the hash of the tree. That's why it's called tree hash. And it's unique, which means if I modify anything inside of that tree, it's gonna get changed. If I don't modify anything, it's not gonna get changed. So it's changed if and only if the tree is modified. Sorry, that was a primer. So tree hashes change if and only if the directory is modified, which means if I take my Docker build directory and I get a tree hash, I have very good identifier. So the whole idea behind our system is we tag the Docker containers with the tree hash. The tree hash is the tag to the container. That means that even if I have the same Docker in multiple repositories, I still end up with exactly the same container. We could have multiple projects that share the same toolchain. Are they the same? If the Docker build directory says so, we end up with the same container. I will I'll show you a little bit of code. I cannot show you our code. It's proprietary. I'm sorry. I didn't ask for permission to show you the code, so I'm gonna show it in this format. Okay. So let's assume our Docker container, our Docker build directory is called docker.d. How do I get its hash? Well, it's very easy. I go ref parse the reference, head, and docker.d. That's my git sha. That would be. Can I go up somehow? I can. That would be hash of my directory. And now our whole script is actually just slightly more complicated than this. This is what we call pull or build/push Docker image. When we want to start our build process, we do Docker pull from my registry, build environment, which is the name that we chose for our Docker container, git ref parse head, head is a head, by the way, so pardon me, for those who don't use it every day, docker.d. So this command is the same, right? Head and add is the same. So we are going, give me the image. The image might not be found. Somebody might have deleted it, or this might be the first time that I'm running it. It might be, whatever. So if it's not found, I run docker build with this tag, the same tag, inside of my docker.d directory, and then I push it in, and that's it. Next person who runs wins here, right? The first unlucky person who runs this will be sitting there for 5 minutes to hours or however long it takes to build it. The next person goes like, got it, or it's possibly sitting on your machine already, and you don't have to do anything, and you are all set. So this is the extent of my code. So how does it work? We run Docker with our in order to give our users build environment. We run our pull or build and push, which was on the previous one. So magic happened. You have all of a sudden you have your image. We start the container. For interactive users, we make it interactive. For non-interactive users, we don't bother. For interactive users, we run their shell, and they do their thing. They all the magic that you guys can do to write a code, which we don't know. We need to do a little bit more. We need to bring the working directory, because it's no good to build it and leave it in the container and delete the container. So we of course bring our working directory and say, oh, by the way, I'm working in the same directory. So yeah, so make it feel like I'm at home. Still not good enough, because that will run as some user, whatever the container says, or whatever the image says, actually the image specification. So what do we do? We get a password entry for our user, store it in a temporary password file. Again, the code is a little nicer in our product, but I cannot just give you our code. And we run it with the same thing. I run it as my user. This is me always. This is always my password entry, and it's gonna look like my user with my ID is running it. So if I make a file, it ends up in my working directory, under my permissions, under my everything the same. We bring a few more things, and I'm not gonna bother you with boring stuff. Somebody might want to make it open source project for all I can. We bring environment variables. Now we bring selection of environment variables because we know our environment, but things like home directory, license server, path and stuff like that, it's useful to have. We bring SSH agent sockets because from within the container, you might need to go to SSH server and, let's say, upload a file or download a file or what have you, execute something on a Jenkins. And for some interactive users, applications, we need to bring X11 sockets. That gets complicated really fast because you might be X11ing over Unix sockets, or you might be X11ing over TCP sockets. For all we know, you might have SSH to that server and have the sockets forwarded from Unix socket to TCP socket and so on. So this gets complicated really fast, but it's just a matter of doing the code and doing all the ifs and stuff. So so this is how we start. So if you put make in here instead of bash, you're building. If you put bash in there, you have your interactive shell. I think that's pretty much what I wanted to show you how this is done, and then just conclusion of the story. Am I running too long?
No.
Good. So everybody rejoiced, right? Of course. I mean, that's the end of the story. Yeah. Okay. No, fine. Not really. People are complaining. The transparency is not 100%. It never will be 100% because we are talking about separate namespaces by the Linux kernel. Sorry. The other problem is that if you have a SDK and it's inside of the Docker, then the header files are inside of Docker. So if you wanna go and grab what is value of in other any, right? Well, you better do it inside of the Docker, or you just extract them out. I mean, you can copy them out. I mean, it's no big deal. You just need to know the command, right? The Docker images are big, and if we have developers who are lucky or unlucky enough to work on maintenance, that they are during the day working on the new product, at night doing the maintenance, right? They will have 2, 3, 4 images. Those images are huge potentially, so we need to clean up, but it's a small price to pay considering that you get your environment on the same machine right away without any problems. And about 2 years after we did this, we finally got test that one of our developers in the middle of the night actually came to me and said, we need to do maintenance release, and is it gonna work? And I said, well, sure, why don't you try? It did work. So this is actually proven thing to work. So it's not a bad idea to version control your Docker images that way. Okay. The moral of the story, I guess. So, children, what did we learn today? We just took two simple concepts: Git hashes and tags from Git, and we marry them together, and it creates something better than those two things alone, which is really good, and it doesn't take too much to create simple things that really help you. We believe that telling developers what they did and making them see how it works is always good. Engineers always want to open the back lid and see what's inside. Let's make it transparent for them, because developers are smart and we need them to be smart. And just sometimes we don't need solution to create something that really works. Sometimes just a simple tool, just such as this, is enough. Leave it to developers. They are smart. They will figure it out. They will get a good use of it. And if anybody, not many people, when I say all these nonsense words, nobody's smart, so nobody has aspirations to be project manager, I guess. So forget about solution and management things. Simple tools usually work for developers, because that's what you guys are. So that's all I have. That's all I have for you.
Thank you, Hynek. We know that some of you might here be also interested in Thales, so we also like to give you an overview of our company. So we have Andreas here to make a quick presentation about Thales, and then we can enjoy some cold beer. But if someone wants now a cold cola, we also put it in the middle of the table. And if you have any questions about Docker, just go to Hynek and he will answer everything.
I thought I'm supposed to go back to work. No?